Hey, right now, I want you to lock in and really look at this expression. What is the value of this mathematical expression? This exact problem, yes, this one right here, has gone completely viral. We're talking millions of comments, flooding platforms like Facebook, Twitter, YouTube, people arguing, debating, completely split on what the answer actually is. And here within, I'm not here to add to the noise. In this video, I'm going to walk you straight to the correct answer. Now, this problem right here, this is a pure example of the order of operations. I need you to see this clearly. This is what we commonly call PEMDAS, or sometimes same idea, same structure, same exact logic. And I'm going to walk you through it step by step. No guessing, no confusion. First, your eyes go here, parentheses, brackets, anything grouped together. That's always where we begin. Then immediately after that, we move up to exponents, or what some systems call orders. Those powers, those superscripts, they come next. No exceptions. Then we drop down into multiplication and division. And listen carefully, this is where people start making mistakes. Finally, only after all of that, we land on addition and subtraction. Now here's the critical detail. This is where everything either clicks or completely falls apart. When you have two operations with the same level of priority, same precedence, you do not pick randomly. You go from left to right. Exactly as it appears, no shortcuts, no skipping left to right. Now this first part of the problem, there is zero controversy here, none. I want you to look directly at this expression. It contains a parenthetical expression, which means by the rules we just established, this is where we must begin. Inside those parentheses, you see it clearly, 1 plus 2. So we evaluate it immediately. 1 plus 2 gives us 3, clean, precise, no debate. Now this is where things start to get interesting. The question becomes, what do we do next? If you take this exact expression and plug it into Google, into Wolfram Alpha, or into almost any scientific calculator, watch closely, because they will all do the same thing. They will interpret the parentheses as an implicit multiplication. In other words, this 2 sitting next to the parentheses and that 3 we just got, they don't stay separate. That 2, 3 is immediately understood as 2 times 3. Now, we continue. Stay with me. At this stage, the expression in front of us contains only multiplication and division. That's it. Nothing else is left. And this is critical. These two operations have equal precedence. So what do? We go left to right. No hesitation. Start right here on the left. Use 6 divided by 2. Lock in. 6 divided by 2 gives us 3. Now we move forward, step by step, no skipping. We now have 3 multiplied by 3, one final multiplication, and that gives us 9. That's it. Keen, exact. This is, without a doubt, the correct answer to this expression, exactly as it is written, following the modern usage of the order of operations. And now the real question is, why did this problem explode into so much controversy? Why are millions of people completely divided over something that seems this precise? Here's why. There is actually another answer, yes, another one, but you could argue for if you step into a historical perspective. And this is where things get fascinating. I went back and looked at actual documentation, and what you find is this. The order of operations didn't always mean exactly what it means today. In fact, in certain mathematical texts around 1917 and earlier, there was a slightly different understanding of how these operations were interpreted. Now watch this carefully, because the first part of the equation does not change. It's exactly the same as before. We still have a parenthetical expression, and by the rules, we evaluate that first. You see it right there, 1 plus 2. That becomes 3. No debate, no ambiguity. But now, this is where the entire argument begins. Everything centers around this division symbol. I want you to really look at it. What does it actually mean when we write 6 divided by 2, 3? Here's where history steps in. There were textbooks widely used that interpreted this differently. When they wrote something like something on the left divided by something on the right, they didn't just take the next number. No, they treated the entire expression on the right as a single unit. So instead of reading it piece by piece, they grouped it. Let me show you exactly what that means. If a textbook wrote x divided by 2y using that division symbol, they didn't mean divide by 2 then multiply by y. They meant x divided by 2y. That entire product, 2y, became the denominator. One block, one structure. So under this historical interpretation, which, yes, is a special exception to the order of operations and we don't need it anymore, you would take everything on the right side as your divisor. Apply that idea right here. You now reinterpret the expression as 6 over 2 times 3. Now stay locked in. We evaluate the multiplication in the denominator. 2 times 3 gives us 6. So now the entire expression becomes 6 divided by 6, and that gives you 1. So now you can see it. This is why so many people argue that the answer is 1. And to be fair, there is some historical justification for that position. It comes directly from the way the division symbol used to be interpreted in older mathematical texts. Now think about this, because this is actually fascinating. One reason for this interpretation likely comes from a typesetting limitation. Back then, it was much easier to write a simple division symbol and just assume the reader understood the meaning. Everything on the left divided by everything on the right. Clean, compact, efficient. Because if you didn't do that, then what would you need? You'd need to write full fractions, numerator over denominator, which takes up more vertical space. You'd need parentheses everywhere, constantly clarifying structure. So instead, this shortcut became something that was simply understood. But today, we don't do that anymore. Why? Because it creates confusion, exactly the confusion you're seeing in this problem. Instead, we follow the order of operations strictly. And if we want to express a fraction clearly, we write it explicitly like 6 over 6. Exactly as you see here. So when we interpret this expression using modern conventions, the correct answer is 9. Now yes, there is historical justification for the answer 1, but that is not how we interpret the problem today. So let me ask you, did you arrive at 9? Thanks for watching. Subscribe to the channel. I create content on mathematics and game theory. You can also find me on my blog, Mind Your Decisions. Follow along on Facebook, Google+, and Patreon. And if you enjoyed this, go check out my books. Links are in the description.